Welcome back to 10minsPaper, where we dive into the latest scientific discoveries in under 10 minutes. Today, we're exploring a groundbreaking study on integrated optical frequency division for microwave and millimeter wave generation. Let's unravel the future of communication and sensing systems together. Imagine the potential of ultra-low noise microwave and millimeter waves, miniaturized on chip-based platforms. This innovation could revolutionize radar, communication, and sensing systems. But how? Optical frequency division uses optical references and frequency combs to achieve unparalleled spectral purity in microwave generation. The researchers have miniaturized this system onto a chip, compatible with standard semiconductor processes, opening doors to mass production. At the heart of this system are soliton microcombs generated in microresonators, achieving record low phase noise for photonic microwave oscillators. This integration could mean more stable, cost-effective applications for everyday technologies. The magic lies in the phase stability provided by a large mode volume optical reference cavity, and the division of frequency from optical down to millimeter wave, all on a tiny chip. Traditionally, achieving such low phase noise required bulky setups. But now, we're looking at delivering similar or better performance in something as small as a coin. This breakthrough could pave the way for advancements in 5G/6G communications, radio astronomy, and more, by enabling low-cost, high-volume manufacturing of these critical components. The future of communication is bright, and it's being written now, on silicon chips. For more details on this fascinating study, check out the link in the description. Don't forget to like, share, and subscribe to 10minsPaper for more scientific discoveries explained in under 10 minutes. Until next time, stay curious.